How do you solve this equation? We have the equation x squared minus x equals 3. Today in my various classes we went over this problem, and the main thing is to look at here is what is your instinct, what does your intuition tell you to do first? And when I asked this question to my class today, I had a variety of answers, one of which was to go ahead and try to put numbers in the place of x and see eventually which one would come closest to satisfying this equation. Well, while that's a method that could work, it's one that's very inefficient. And another way I heard was if we go ahead and solve the left side for x squared, and we add x to both sides of this equation, what we have is we have x squared equals x plus 3, and then if we take the square root of both sides of this equation, we have x is equal to plus or minus square root of x plus 3. Now surely you have solved for x on the left side, but you still have that unknown on the right side, so this really doesn't work out. Well, what your intuition should be is to solve the right side of the equation for 0, and we can do that by subtracting 3 from both sides, and so what we have now is x squared minus x minus 3 is equal to 0, and you can take this and now solve by graphing. If you have a graphing calculator, you can put it in like this: y equals x squared minus x minus 3, and then you can see where the graph touches or crosses the x-axis, and those would be your solutions. And so but the next thing you're going to try to do, and this is what setting 0 helps you to do, is we can go ahead and solve by factoring. If we can find two linear factors of x squared minus x minus 3, we're going to be able to solve quite easily. And so what you have, you're looking for two numbers which when added together are -1, but multiplied together are -3. So if you multiply 1 by quantity x plus 1 by quantity x minus 3, you're going to get 1 times x, which is x, but over here you're going to get -3 times x, which is -3x. And you add these together, you get -2x. And -2x, we need to get -x. So this is an example of a quadratic expression that is unfactorable. And if you have an unfactorable expression, you have different things you can yet do. Maybe the most popular of which is use something called the quadratic formula. Now the quadratic formula I'm going to write at the right here. It's going to be x equals -b plus or minus the square root of b squared minus 4ac, and that's going to be all over 2a. Now what are these a and b and c, you ask? Well, we have the expression in standard form on the left. That's going to be 1 x squared, so a equals 1. We have -1x, so b is equal to -1, and c is equal to -3. Now in the quadratic formula, what I recommend doing for my students is any place there's a letter, you go ahead and put a parentheses to be filled in. So you have the first parentheses in place of this b. We have plus or minus the square root of, we have b squared minus 4 parentheses, parentheses, all over 2 parentheses. And what you do is you put the numbers in the place, and when you organize it this way, it's hard to get it wrong. So we take any place you see an A, you place 1, so 1 goes here and here. Any place you see a B, you put -1, as here, and -1 here. And finally, C occurs in one place, which is right here, so that's -3. And now what you do is you can simplify. X is equal to, we have 1 plus or minus, we have 1 minus 4 times 1 times -3, so we're going to get square root of 13, and that's over 2. So our answer is going to be 1/2 plus or minus square root of 13 over 2. Now there's another way of doing this, which is called completing the square, and I'm going to just quickly do this on the left side. and then you can kind of compare, see which one you like better. So what we have here is we want to rewrite this x squared, and what I'm going to do to leave myself room, I'm going to erase all this. I'm going to put, we do to complete the square, we're going to take this x squared minus x, and then we're going to add some number that's going to be used to complete the square on the left side, and on the right side we're going to have 3 plus some number, and these blanks here are going to put the same number in place. What number goes in here to complete this square? What you do is you take the coefficient of this x, which is -1. So what we have is -1, and divide that by 2, Dr. Hoffman square we say. And you take this, now you take this -1/2 and you square it, and you get 1/4. So 1/4 is the number we add on both sides of this equation. And now what we have left is we have the square is going to be quantity x minus 1/2, and we square it, and on the right side what we have is 3 is going to be 12/4, and 12 plus 1 is 13, so we have on the right side now 13/4. That's going to be simply 3 plus 1/4. And now we take the square root of both sides of this equation. What we have is x minus 1/2 is equal to plus or minus square root of 13/2. And then when we add 1/2 to both sides of this equation, what we have left is x is equal to 1/2 plus or minus square root of 13/2. So we get the same answer either way. I don't know which way is easiest for you. I know that in my mathematical career I used to be more comfortable using the quadratic formula, but I've sort of evolved to being more comfortable now with completing the square. So I hope this has been helpful to you. Good luck, and thanks for viewing.